Am I audible? Hello.
Yes, sir, audible.
So in the previous class, uh, we were discussing about IoT network architecture and design. There, just we have had a analogy between a construction of a house is equivalent to construction of a traditional IT network. It means much architectural approaches are not required there since the IT network has a limited number of devices and network internet. Okay, but when we want to construct IoT network, so that can be compared with the construction of a big structural buildings like stadium or any other multiplex or mall like this. Okay, there much architectural designs and approaches are required. So this much we had studied, and also we had studied some of the designations in companies and what are the demands, how they are how they have a demand in a job in their role. These are all things we studied. After that, I think we have also studied the drivers behind those network architectures. It means that the challenges which are faced by the IoT, which are making to become a success that IoT. So it means that they are the motivators for those IoT to become a success. So those all challenges, if we address those all drivers, if we address, then definitely IoT will become a successful technology, right? So those challenges only we were discussing in the previous class. In that one, first challenge was scale. So as I already told you, so there are many number of endpoints or sensors or things or devices are connected to this IoT network, right? So here, what is required now, the change, the modification which is required in the existing architectural pattern of IoT is, so there should be a transformation from old method to new method. That is, earlier we were using IPv4. Now, since the number of devices are keep on increasing, now onwards we should start to use IPv6. So in computer network, I think you have studied the transformation from IPv4 to IPv6 and what is the advantage of IPv6 over IPv4. These all things you have studied. So here also, since the number of devices are keep on increasing, there should be transformation from IPv4 to IPv6. Then security, since the number of devices are increasing day by day and the network size is also increasing, so definitely in every level, each level of the network, we should try to provide the security. Not only in the core level of the network, but we should also provide the security in each and every level of the IoT network. Each and every level of the IoT means what? So wherever you have installed your sensors, wherever you have attached your sensors, so in everywhere you should provide a security to that sensor, right? So this is about security. And next is next challenge is devices and networks constrained by power, CPU, memory, and speed, everything. Since the distances are long distances now because one device may be remote and another device may be in another place. So these all speeds, data transmission speeds, or you can say data rate. The data rate earlier it was low in terms of just 10 bits per second to 100 kilobits per second. But now we have to increase the speed even though the distance is long. Okay. So these are type of advancement improvements we have to bring in the IoT network. Okay. Then massive volume of data generated. Obviously, day wise, if you calculate, every sensor is producing a huge amount of data, and at the end of the day, you will get a bulk amount of data, and we have to think about it, where we have to maintain it, where we have to store this data, and how we can use this data in a better way, or who can use it. So these all things we have to keep in our mind. That is about a massive volume data generated. So here, earlier the data was only stored in only cloud. Okay, so now the required change is what here. So now our devices, our sensors should be having a capacity to store at least some small amount of data in their levels only. So by doing this, what happens? So whenever we generate the huge amount of data, so we can reduce the traffic in a network. Otherwise, what happens in a network, in a network, traffic will be increased and it will make that traffic as a bottleneck. It means huge amount of data is flowing from each and every sensor to the cloud. Okay, so this type of improvements we have to bring in our IoT technology. Then next one is support for legacy devices. So it means that so earlier we have some IP capable sensors and some other devices which are non-IP devices are also there. So these both of these type of devices we are using in our network. And also what we are using some protocols here, right? So it means that IP is already protocol actually, internet protocol, IP capable. It means that we can address each and every device with the IP addresses, and some things are there, some devices are there which cannot have IP address. Those devices also we have included in our IoT, right? To connect. So because of that only, both IP capable endpoints or sensors or devices as well as non-IP devices also we can use, as well as along with them we are using some protocols here. But here, what is the change is required now is the digital transformation is a long process. So digital transformation is nothing but a digitization. This digitization is a long process, and as I already told you, there should be some transformation from old traditional methods to new technology, right? So for example, I have given the example, we have to move from IPv4 to IPv6. Similarly, the same thing is here I have written, that is tunneling mechanisms we should start to use, or else we should start to use the protocol translation mechanism. Okay, we have to support this protocol translation or else the tunneling mechanism. Protocol means what? It is a set of rules, right? Set of rules which is understood by the both the parties of a communication parties. If one device is understanding a protocol and another device is not understanding that protocol, then there will be not there is a data transmission is not a possible there. So because of that only, that protocol should be understood by the both the parties. So because of that, it should support protocol translation as well as some other technologies like a tunneling mechanism. Tunneling mechanism in IPv4 to IPv6 transformation, we have studied this. Okay. So such kind of protocols we should start to support and use. Then next challenge is the need for data to be analyzed. See, in real time, however, the sensors are keep on generating the data, keep on generating the data, that data should be analyzed. That data should be analyzed in real time. So in earlier days, in traditional IT, so this data analysis was scheduled based on a batch processing. Okay, so batch processing of data. So here data needs to be analyzed and responded in the real time. Even now also we should continue the same batch processing or batch level data analytics, but what should be there is there are some new technologies like big data and Hadoop, and we should start to use some relational databases. This type of technologies we start to use here. And one important thing is there are some softwares are there to analyze these data. So those data analytics softwares, okay, those data analytics softwares those data analytics softwares should be used by us, and these softwares should be installed in those edge uh, devices, or in every sensor, so that data, however the sensor is generating immediately in real time, that data should be analyzed. Okay, so these are all the challenges, and or else we can call them as a drivers. It means that these challenges only if we address, we can achieve the success in the IoT technology. So these challenges only we can call them as a drivers, or the drivers behind the network architecture. Okay. So next, today we will go to next topic, that is comparing the IoT architectures. So actually two architectures are there for IoT network. Okay, today just I discuss only first architecture. In next class I discuss the second architecture. Okay. See, these architectural standards, or you can directly call them as architectures, or else frameworks. They have they have emerged. It means they have developed to address the challenge of designing the IoT networks. Correct. So these IoT architectures or these frameworks are designed or constructed. The main purpose was to to address the challenge. It means to solve the problems or issues, whatever just now I discussed. And challenge of what it is, challenge of designing the IoT networks. And particularly, which IoT network it is? It is a massive scale IoT network. See, so why it is a massive scale IoT? Because the number of devices are day by day keep on increasing. Correct? So designing a massive scale IoT network we want to design. So to design this one, we should have some architectural standards. Based on that, keeping that architecture as a foundation, we can start to construct the IoT network. You just think about this network as a topology, topology of our computer networks. So based on that architecture only, we will develop our actual network, right? Similarly here also, to construct IoT network, that to massive scale, it means huge number of devices are there. So obviously the size of these IoT networks will be large. So to design these large IoT networks, we should have some architectural standards or frameworks. And the concept in these all architectures is, the only thing is, the concept is nothing but the focus. The concentration or focus should be on supporting the data. Okay, of course. So because the devices or sensors are generating the data there. What type of data? Any type data. So there may be any kind of data may be generated by the sensors. So supporting different type of data, and supporting the processes, and supporting the functions that endpoint or end devices are performing. Endpoint or end devices are nothing but the sensors and other any things, whatever you have included in your IoT network. Those endpoints, end devices, the whatever the functions they are performing, whatever the processes they are doing, and on some data they are processing. So these are type of data and process and functions we should support. That should be the constant, the goal of that architecture. The architecture should support the data, it should support the process, it should support the functions which are performed by these end devices. And mainly there are two types of IoT architectures are there. The first type is one M2M. Okay, first architecture, IoT architecture is one M2M. Second architecture is IoT World Forum. IoT World Forum, in short, we can call it as IoT WF. So let us today discuss only first one, first architecture, that is one M2M. So what is this M2M? So M2M is nothing but machine to machine communication. Okay, machine to machine communication was earlier. Okay, one machine used to communicate with the other machine, and slowly everybody started to use this architecture to make the computers to communicate with each other. So then slowly, whenever this architecture or network was started to expand, or its size is started to enlarge, It means that, so it started to include IoT, okay, IoT devices in its network. Then instead of calling it as a M2M, they have just renamed it as a one M2M. Okay, so one M2M is a IoT architecture. So in this architecture is not only making the machines to communicate. There are some other things are also there which are communicating with the machines. Okay, so because of that only it is called a one M2M. Otherwise, it would have called it as a M to M only earlier. Now it is IoT is also involved here in this, included in this network architecture. So it is called as one M to M architecture. So here this is the architecture of IoT, that is first architecture, one M to M architecture. Here this question may be asked in your exam. For 4 marks, and sometimes they ask this question for 8 marks also. Okay, so here they mainly ask you to explain the components or domains of this network or architecture, network architecture. Okay, so here mainly this architecture is divided into 3 components or 3 domains. So first domain is application layer. So, okay, application layer here, they are represented as a vertical boxes here, left side. Okay, you can see here, since its name itself is application layer, the devices and where the devices are having applications. It means where we are using those devices. So there may be any applications here. Just for example, they have given automotive application, home application, energy application. Okay, so not compulsory. So there may be any other applications also may be there. Okay, so these application layers are shown in the vertical lines here. Okay, so next part, next component or next domain of this architecture is services layer. Okay, services layer again consider the same 3 applications in vertical line, that is automotive application, home application, energy application. But this time we are going to show these services in the horizontal lines, that is common service layer, communication technology and protocols, communication networks, communication devices and hardware, like this. Okay, so first is a application layer, second is a services layer, third one is a network layer. Okay, so let us see these all 3 components here one by one. The one M2M architecture divides the IoT functions into 3 major domains, as just now I told you. So you can call it as a component, or you can call it as a functions, or you can call it as a domains. So in three areas, these IoT functions are divided. So those 3 areas are application layer, the service layer, and network layer. That first we will see, that is application layer. The 1-to-M architecture gives a major importance to connectivity. Remember, so this the main focus of this 1-M-to-M architecture is what? Its main attention, its main goal was to connect the devices and their applications. So it is trying to connect the devices with the applications of those devices. Remember, the main focus of this architecture was connecting the devices with their applications. Then this domain contains application layer protocols. Application layer protocol, I think you have studied OSI model and all those things, TCP/IP protocol suite. Okay, I think no need to explain these all layers. So this layer or domain or this component contains, as its name itself, it is an application layer. It contains application protocols, obviously, and along with these protocols, so there is one more thing is there, that is API definitions, that is application programming interface definitions. So for communication purpose, there are some interfaces are there. So application protocols are present here, and along with application layer protocols, APIs are also present there. And applications are maybe varying from industry to industry. It means So one industry may be using some different set of applications, but another industry may be using some other different set of applications. So applications are not same in all the industries or companies or organization. So those all applications are industry specific. Industry specific means based on the domain, based on the work, based on the type of production of that industry. These applications are varying from industry to industry. So these applications are industry specific and they have their own set of data models. Means they have their own data. It means they are generating their own kind of data or different type of data, and they are shown in a vertical entities here in our diagram. These are called as applications are called as shown in a applications are shown in a vertical lines or vertical box. Okay, so then service layer, come to service layer. This layer is shown as a horizontal framework across the vertical industry application. Already I have shown you, correct? If you consider the same type of applications which are industry specific, that may be industry specific, maybe it may be automotive, it may be home, or it may be energy or something. So same applications if you consider, and across these applications, if you want to mention the services, these services here we are mentioning in the horizontal framework. Okay, and in this layer, it is second layer. In this second layer, horizontal models with whatever I had shown there, these all are actually, they are physical networks. They are physical networks that the IoT applications are running. Here I want to show you this common service layer, communication technologies and protocols, communication networks, communication devices and hardware. You can see here wordings, devices and hardware, communication network, protocol layer. So these all are actually physically existing networks on which our IoT applications are running. Okay, remember, these are physical networks on which our IoT applications are running. Next, in this, the top layer is again common services layer. In this top layer is what is there? Common services. Okay. So this layer, what it does, it adds APIs and middleware supporting third-party services and applications. So it adds some again application protocol interfaces, and as well as it supports the third-party services. Since this layer itself is a service layer, it supports some third-party services and applications. And one major goal of this architecture, M2M, one M2M architecture, is this. In this double quotes I have written from here to here. Try to understand this one. The main goal of this architecture is develop technical specifications. Okay, develop technical specifications which address the need for a common M2M service layer. It means that so earlier already we had started to make the machines to communicate. That is machine to machine communicate with the architecture, M2M architecture. So the same common services, whatever they were present earlier, so those services we have to continue, or we have to include, or we have to adopt them in one M2M also. It means that here also we are going to make the machines to communicate, but apart from machines, there are some other things are also there to communicate with the machines. That is the only thing here. So the goal of this one M2M is to develop a technical specifications which address the need for a common M2M service layer that can be readily embedded. Okay, which is already, it is ready embedded within various hardware and software nodes, and which are dependent upon the connecting the countless of devices. See, this is the important here, which is required for our one M2M architecture. What is that? We are not only connecting a few number of machines, but here we are connecting a countless of devices in the field area network. You remember this field area network is a on type of network which is a large in scale. Okay, in short, you can call this network as a FAN. Okay, FAN, that is field area network. Since its name itself is somewhat like a field area network, it means it is representing a large network. Okay, so n number of countless infinity number of devices if we want to connect, and that network is called as field area network. And this field area network should be connected to now our traditional or old architecture or network, that is M2M application servers. Okay, which are present in a cloud or data center. So these servers, M2M application servers, were present in a cloud or data centers. So to this M2M servers only, we are connecting this network now, large network, so that we can make it as a one M2M. Is it clear? Earlier it was only M2M. To those M2M servers, we are connecting now field area network, which contains the countless devices. Okay. Then the critical objective of this M2M is it is it wants it focuses to attract and actively involve some organizations from M2M related business domains, including telematics. Telematics means it is a study of data communication like mathematics or any other area. So telematics means a study of data communication and intelligent transportation, healthcare, utility. Utility means public services. Okay, so industrial automation, and smart home applications, etc., etc. So these are all things we want to include in this M2M related architectures. So this is the main objective of this one to M2M. So remember these 2 points, very important: goal and objective. Goal as well as objective. This is about service layer. Now come to network layer, which is uh, last part or domain of architecture. This is a communication domain. Okay, this is a communication domain. Because of that only it is called a network layer. So it is a communication domain for IoT devices and endpoints. What it does, what is the use of this layer, how it is helpful. It includes the devices themselves, correct? So then only when we connect these devices, it becomes a network, correct? It includes the devices themselves and communication network that links them, correct? So it means that in simple manner, if you want to explain, it contains the devices and those devices are connected to each other. Okay. In many cases, it is smart devices, or sometimes they are not smart, so much smart also. Okay. So in many cases, these smart devices communicate with each other. So why you are telling that they are not so smart? Because they are not only we are connecting a laptop or mobile phone or smartphone or something, we are connecting some other things are also in our IoT architecture. Because of that only I told you here, not always we are connecting smart devices. Sometimes we connect the not smart devices also, right? So in many cases, the smart devices communicate with each other, and some non-smart devices will also communicate with each other because of advancement in the IoT. But in other cases, machine-to-machine communication is not always necessary. Okay, it means that it is not always machine-to-machine communication is necessary. Sometimes there are some devices are also there. They also want to communicate with each other. The devices simply communicate through field area network. See, I had told no, FAN, field area network, to use case specific apps, applications in IoT application device domain. Okay. Therefore, this device domain also includes gateway device. This is very important. This device domain, it contains a special type of device which is called as gateway. Its name itself is a gateway. It means that it is acting like a border line between two areas. So which areas? Which provides the communication up to the core network and acts as a demarcation point between the device and the network domains. It means it is acting like a border line between device and network domain. So in between this devices and network domain, this some devices are uh, acting as a gateway device. So what this gateway device is doing? So it provides a communication. It just it means that it just act as a link between one person to another person or one area to another area. It acts as an intermediate device. So what it does, it allows the devices and the network domains to communicate with each other. So it provides the communication up to what? Up to the core network. Up to the core network means in the depth of that network, not only the end points. So it provides the communication up to core network and it acts as a demarcation point between the devices and the network domains. Okay, this is about a network layer. So this is a first architecture of IoT, that is 1 M2M, which is important for your exam point of view for 8 marks or for sometimes 4 marks. For 4 marks they ask it. So application layer, service layer and network layer. Clear? So these all are applications which are industry specific. It means they vary from industry to industry. And if the same applications, if you consider, and the services, if you want to mention, these services are nothing but horizontal frameworks. And these horizontal frameworks are nothing but they are physical networks actually. They are physical network. Okay. They are physical networks. Then last one is a network layer. Clear? So some protocols, some application APIs, and these all things you have to explain here. In next class, let us go to next one more architecture is there. That architecture is IoT WF, which is called as IoT World Forum. So we will discuss this architecture in next class. Okay. So you can leave the meeting now.